this wow experience.
Wow! Oh. Anyway, before we get to the tokens, coding with threads in Dyalog, the first thing I did was to write one-liners, because one-liners are atomic operations, and there are no context switches, within the same line of code, with some exceptions. But writing entire programs as one line is kind of like not the idea of any programming language, I guess.
I think it will not work.
Huh?
It will not work.
No, it won't work.
No, because it's remotely on my computer, so it should be my computer.
Wow! And debugging an entire program on one line becomes really tricky. Then next is call and hold, which allows you to have more, to split this one line of program into more lines of program. But then you soon realize that everything gets serialized with call and hold. You never have more than one thread being able to take that token. And that kind of poses some limitations too, which kind of leaves us with the token pool. But the token pool is tricky if you start using more than just a few tokens. They're just numbers, but I quickly lose track of what numbers, what tokens were used for what, and are they still in use? Can I recycle that number? And kind of it becomes really tricky, for me at least. And this is the wow experience, because in Sofia, there's some code to cover the use of the token pool, which were implemented by Stefano and Morten. And this is the thing I want to show you. No? You see, this is me. This is me when I discovered this thing. there's a.
I think Stefano must have done 90%.
I'm not so sure. I don't know. There's some central code which takes almost exclusive charge of the token pool, which means that you don't mess with the token pool anymore. You just use these tools. And these tools offer. I have not yet come across a problem of synchronization that I couldn't solve by using these tools, which means that it becomes really easy to synchronize when programming, and that's really neat. This thing keeps track of what tokens are used, and when tokens are not in use anymore, they can be recycled. The first thing that happens is that it allots tokens in ranges. So these are the different tools, the different synchronization things that are in this toolbox. And they each have a range of tokens. So you know that if you have a token in the range 5,000, it's a ReadWrite Lock. And this is what the toolbox does when it initializes. It has a vector of all the tokens that are in use, and these are the ranges in which those different tokens can be used. This is the Latch Object. Basically, it's just a token with a positive number. You have a worker thread, which creates this latching object, launches another thread, and then enters a loop where it waits for this object. And whenever the parallel thread opens the latch, this thread continues until it reaches the wait again, and waits here until the next open latch is executed. See, no token numbers, nothing. It's just really neat. This is some of the code, which is really simple even. We create the latch by asking for a new token, and then you just put it in a namespace. When you ask for a new token, it cycles through the range of all tokens for that kind of object, takes the first token it finds available, and assigns it. This, of course, has the risk that it might run forever because there are no free tokens, and I've been there. But that's a bug, because if there are no more tokens to be used, then it's because I don't recycle the tokens. So it's really my own problem. And the open latch just puts the token in the pool. Next object, the gate, which is really the latch, except the latch is a one-shot gate. The gate, when opened, doesn't remove the token, because it's basically a token with a negative number. So this thing keeps looping until the parallel thread closes the gate, in which case the worker thread then stops at the wait until the gate is opened. What happened? This is more code. When the gate is closed, it just removes the negative token from the token pool. The wait basically just calls tget with or without a left argument. Without the left argument, it waits forever. With the left argument, it times out after some time. Yeah. Next good thing about the tokens, they can contain data. So it's really easy to make a synchronization object using a token, because you just stuff your data inside the token and you're done. So basically, it's like the latch. You create a sync object. You start a parallel thread. Once you have done your calculations here, you need to pass results from one thread to the other. You just stuff the data inside the sync object, and the main thread, when it exits from the wait, it has the result that came from over here. And then you dispose the sync object to recycle the token. More code, basically the same thing, but just put the data as a left argument to the quadtuple. Another good thing about tokens is that the token pool is first in, first out. So it's really easy to make a FIFO queue using the token pool. It's basically just multiple tokens with a positive number. We create the queue, and you wait for items to appear in the queue. These items are enqueued by other threads, and whenever it comes out, when this thread comes out of the way, there's an item to be processed, and they always in the order they were put in the pool. More code, but it's just the same. Gets a token, puts the number of the token in a namespace, and when you queue the item, you just put the token in the pool. And the best of them all, the last one, the ReadWrite Lock. Basically, it's a thing with a token with a positive number and a token with a negative number. You first create the lock, and whenever you need read access to the resource, you just call wait read on this object. And when you need write access, you do the same thing. When you're done with your access, you release the hold. You release the hold, and that other take charge. Is the code. It asks for 2 tokens in the range for ReadWrite objects. It has a counter which keeps track of the number of read accesses out there. Put these 3 in a namespace, and then puts the right token in the pool. And this is the code for the remaining bits. If you want write access, you remove the write token from the pool, and then you wait for the tokens for the remaining threads that have read access. When you're done with your write access, you put the token back in the pool, and you reset the counter for read access, because there are none at this point. If you want read access, you ask for the write pool, but you ask you ask for the positive value of the right token, so you don't remove it from the pool. You increase the number of read accesses by 1, and you go. When you're done reading, you put a read token in the pool if the right token isn't there, which means that once the right token has been removed from the pool, you know exactly how many read tokens to wait for before you have write access. And this is why it puts read tokens in the pool only when the right token has been removed. And when you release your read access, you decrease the counter by 1. Stefano did this.
I'm pretty sure Stefano did this. I have no memory.
So, to sum up my little speak, tokens can contain data. The token pool is first in, first out. And because this code is what you call it, legacy code, there are no classes or anything, but classes would be really ideal to make sure that the tokens go back in the are removed from the in-use vector when they go out of scope. When at university, I had a class on concurrent programming, and we used the Ada programming language for that. So this seminar, this day on concurrency, kind of reminds me of Ada. And she has now become a cartoon. There's a Canadian woman in London who draws this cartoon, and it has been published. This is a parallel universe in which Babbage actually manages to build his analytical engine, and they use it to go fighting crime like street music and poetry. Yep, that's it for me.
Thank you.
Yeah.
Not a question, but a remark.
Yeah.
You said that in order to make an operation single unit, you have to put it on one line. But it is actually not true. And it's important to realize that. When you have a defense, a multi-line defense, with switch thread only in line 0.
Huh.
But not after it has entered line 1.
I didn't know that.
Except when you call another defense, because then you end up in line 0 again, and then you are again thread might switch or might not. But that is important to keep in mind, because if you have a 50-line defense and you think that in between other threads have a chance to jump in, no, they don't. And that is important to know.
Yeah.
I only learned this myself a few weeks ago.
Well, actually, there's a story behind this. I made exactly the same statement you made when I was visiting Dyalog in Bremen. Jay Fold said in the background, that's not true. It's not switching in dynamic functions. And John Daintree said, yes, they do. And Jay Fold said, no, they don't. And it became a heated discussion, and Jay Fold won. He knew exactly what he was talking about.
I see.
I like the looks of this library. Could it be open sourced?
Oh, I don't know. I'd have to talk to Stefano.
I have already asked Stefano that question, but
Okay.
he is not answering.
Oh.
You're thinking.
Now, to give some examples, what do you actually use this point here?
I use the ReadWrite Lock for an index of registries that are available to traders, and this vector of numbers might change during the day. So the vector will have to be updated live. But to make sure that we don't get inconsistencies between what traders can see, what order registries and the like, I use the ReadWrite Lock to update this vector. So I make sure that nobody can see this vector while I'm updating it. And once I'm done updating it, everybody can see it at once, simultaneously. Otherwise, I use it. I use one of the simpler ones for like when I have to kill one of the Sofia services, or the what do you call them? The headless dialogues. When I have to kill one of those, I need to know that they are in a safe state. So I have a latch, not a latch, a gate, which I can close from a web browser, and then the service will tell me when it has reached the gate, and I can kill it.
Right.
So I don't use it all the time, but occasionally I find need for it.
Do you use threads without using this library?
Yes.
So there are use cases for them.
No.
In Sofia.
That was before I knew this library existed. I used quad T-put, and Stefan got very angry with me. But assigned a range in the init function with tokens just for me.
Oh. That's very kind. Well, if we don't have any more questions, I guess I'll thank you again. And
Can I have a question?
Sure.
Yeah.
Yeah, we have
Sofia or Sofia, is that a product? Or
Yes. It's like SimCorp's Dimension, except on a different scale.
Yeah.
Yeah.
Okay. So it's not, you want to provide a workspace or something, this functionality in it, or what?
Yes. Well, there's a code management system in Sofia with all kinds of libraries and groups of functions within the libraries. In one of those libraries, in one of those groups, all these functions are kept. So they are available to all the programmers in Sofia.
Yeah. But also outside.
Outside, well, I'll have to talk to Stefano if this can be made publicly available. I'm pretty sure he's keen on it, but I have to make sure.
if he doesn't, we'll rewrite it.
Sure.
Right. Okay. Thank you very much.
Well, thank you.
I just realized I have to carry my laptop around.
Yeah, but also the other thing might.
Let's see if I can pull this without unplugging anything.
So, and then you ask it a small question. Yeah. And with an open threading, responds immediately. So that is the
Yes.
if you want to do open threading, then it's no, you're absolutely right. In fact, if you do it like this, yes.